Hi, welcome to my presentation. My name is Enock Mbewe. I'm a second-year PhD student in the Department of Computer Science. My supervisor is Dr. Josiah Chavula. My work aims to investigate the use of a security decision configuration model to allow users, especially those with limited computing skills, to easily configure their desired level of security informed by the course of the security parameters. By course, I mean the performance degradation as a result of security, or if there is any performance improvement, or if there are any security vulnerabilities associated with the choice. Yeah, so generally, this research is motivated by the increased cybercrime on the internet. As you know, the internet penetration is increasing, and the cybercrime is increasing as well. So it only makes sense if we empower the users to make their own security decisions, unlike the state of the art where the security decisions are centralized at those places of power, for example, internet service providers and corporate networks, network administrators. So generally, I would like to answer the question: to what extent would the use of decentralized, cost-aware security decision model improve adoption of security mechanisms and quality of browsing experience? So I'm looking at two factors: adoption and quality of experience. So this study follows design science approach. It uses both active and passive measurements, and we are involving users at every step as well. We conceptualize a cost classification engine, as you can see from this conceptual framework. This classification engine would classify different combinations of security parameters against associated costs and present them as a comprehensible list of choices, which users will use to configure their desired level of security. So far, we have been able to calculate the cost of DNS security protocols and transport layer security ciphers. So these graphs show DNS timings for plain text DNS versus secure DNS, and from different providers. And we also measured the performance of different DNS providers from different countries. So far, we measured from 7 countries: Malawi, Kenya, Uganda, South Africa, Nigeria, and Zambia. Then we went ahead and to measure the median page load time differences between the plain text local DNS resolver versus the DNS security protocols against content hosted in different continents. In this case, we measured against Africa, America, and Europe. So in a nutshell, we observed that DOT, DNS over TLS, performs better across providers, while we noted that DOH is affected much by the distance to the content and distance to the DNS providers. So in our next steps, we want to design the model and evaluate it. We aim to finish in 2021. We say our thanks to House of Platinum for Institute for Digital Engineering for financial support that they gave us, and they're still giving us to conduct this research. Thank you. Let's meet and engage